If you use industrial fluids to manufacture your parts, we know two things about your process. First, we know that a certain percentage of your systems are operating within their target or optimal zone. In these systems, fluid performance and impact on the operation is positive. OEE is high, plant resources are being properly utilized, and costs are being well managed. The second thing we know about your process is that you have variability. Variability from system to system, as well as day-to-day variability across those same systems. It's this variability that drives your costs up unnecessarily, taxes your resources, and puts your people or process at risk. This is true if you run a tightly managed world-class organization or a company that struggles to reach the productivity goals that have been set. Struggling companies also have pockets of systems that are well managed and maintained. The difference is that higher performing companies are able to manage and maintain a higher percentage of their systems within their optimal zone. Now, we're not saying that world-class companies don't suffer from variability. The difference is these same organizations are able to maintain a tighter and taller profile related to system performance over time. So what separates high-performing companies from lesser ones is the degree of variability in the factors that drive process performance and cost. It's hard to overstate the impact of even a modest change and increase in the average percentage of systems that are being managed and maintained within their target zone over time. Fluid condition can only exist in one of three states. It's either performing its designed function, it's putting the process or people at risk due to its condition or contamination levels, or it's being used in a wasteful manner. More fluid, more waste, more resources are being used than necessary. The volatile nature of fluids combined with the stresses of manufacturing keeps fluid condition moving between these three states at all times, unless timely and appropriate corrective actions are being taken to maintain them within the target zone. Knowing what to measure, how often, and cost-effectively correcting for that condition is essential to establishing robust controls and reduced variability. Unfortunately, root cause analysis to determine all the process variables that need to be managed requires good data, combined with specialized expertise. Historically, many facilities haven't had the data or in-house expertise to determine root cause, and therefore many of today's preventative maintenance programs are based on containment steps taken to react to a manufacturing event. Let me try and illustrate. Let's say on a hot and humid day, a wash process was not able to produce a part with sufficient rust protection to meet a customer specification. A rust event occurred, and in an effort to quickly address the problem, the decision was made to dump and recharge the system. Now the problem went away, and the cost of poor quality significantly outweighed the cost of dumping and recharging the process. So another decision is made. The washer is put on a 90-day PM schedule moving forward to avoid it from happening again. Now, why is this wasteful? Well, because the rust event had nothing really to do with the fact that the fluid was more than 90 days old. Let's take it one step further. There are 8 other similar washers in this facility, so again, in an effort to avoid a quality event, all 8 washers are added to the PM program. The incidence of rust goes down, but the preventative measure drives costs up, taxes resources, while the risk of reoccurrence still exists because the root cause was not determined and managed directly. By not determining the true root cause, risk of reoccurrence remains, while wasteful steps are added unnecessarily to the manufacturing process. These steps stack up, one on top of the other over time. Fluid condition variability, where true root cause is not understood, inevitably leads to wasteful plant practices. How your fluids are being managed and maintained can significantly impact how quickly you can reach the goals you have set for the coming year. More than the cost of fluids, their day-to-day impact on the operation has a cascading effect across all departments. So what's truly threatening your goals for this coming year? No, it's not sharks, it's process variability. Variability of process parameters that might not be recognized as root cause threats. Threats that hurt productivity and overall profitability. By taking variability out of the process, by learning the true mechanisms of cause and effect, by understanding the various thresholds where fluid condition can negatively impact the process, you're able to better allocate your strategic resources, eliminate wasteful activities, and drive predictably towards your desired results. Find out what percentage of your systems are operating within the target zone, how many are putting your process at risk, and how many are wastefully driving your costs and taxing your limited resources. Our process profile audit takes a snapshot of your facility, identifying the systems in the target zone, in the event zone, and in the waste zone. Find out whether fluid condition is putting your process at risk, or if past events have driven your PM programs deep into the waste zone. To get more information about our process profile audit, please provide your email address at the end of this video, and we'll forward you more details on how the process works. Thank you for your time and for your interest.